Hello again. I'm back with another video, and this time we're gonna look at the Snakekeylogger. So I didn't find anything related to analysis of this malware on the internet, so I decided to take a look at it. Now, this is malware that is based on the .NET framework of Microsoft. Now, I don't have too much experience with this, but I am just going to noob my way through this, and I hope you will enjoy this video. So let's get started. I unpacked the sample. Let's throw it into Detected Easy. Here is the .NET Framework version 4. And if we take a look at the entropy, there is clearly something in here that is packed, encrypted, or otherwise obfuscated, as the entropy is at a maximum here. So next, let's load this into dnspy, and then we can just go through it step by step. So I'm just going to load it in here. Here we are in dnspy, and there's a couple of things here. You can see Hewlett-Packard. That's of course nonsense. Then we have this pharmacy management system, which is also nonsense because this is clearly malware. And when I first analyzed this, I just stepped through, had a little look around here, and strings here like this, these with these weird Unicode characters in here. This pretty much tells you usually that this is obfuscated in some way, and there is actually a tool you can use for deobfuscation, which I will show you now. So the tool to deobfuscate these .NET-based executables is called de4dot. Now I have a different version here. It's called de4.cex. You can just find this on GitHub, and there's a release here from January 10th, 2020. You can just download this, unzip it, and then use it as a command line application. So here I have the path to the executable, and if I just run this, you can see it says, okay, it's detected an unknown obfuscator, and now it's renaming all the obfuscated symbols. So if we look in here where I had my original executable, you can see that de4dot stores the executable with this -cleaned, and this is then what we're gonna throw into dnspy. I'm just gonna close this up here and throw it in again. And then you can see that these symbols are now readable, so that our work becomes a little bit easier here. So here we are at the same point where we were before, and now we have method names, and the contents are already more readable, so that's pretty cool. de4dot helped us quite a lot here. Now, if we look at the resources, when I first had a look at this, I always looked through the resources, and there is this resource here, kind of a weird name. Now, if we look up here into these resources and just open these up, we eventually reach the name that we found below this resource, and you can see it's quite large here. And it looks kind of funny. So this is going to be the encrypted part that we want to get a closer look at, which is probably just the next stage of the payload. So I am going to show you how I got to the decrypted version of this. In the next step in my analysis, I wanted to find out where this resource is used, where I suspect that this next stage is. So to find that out, I went ahead and I just did a right click here on this resource and said analyze. And from that you get this analyzer, which is quite neat. And I just clicked my way through here. I just wanted to see, okay, what is this used by? So or who uses this. So I went ahead and checked out all of these methods here. for instance, this S method 3 in here, and just clicked my way through pretty much. And eventually, as I came up to a little bit of a dead end here, I found inside of this getSS, which is the next resource in the list. It's also a weird name. This login ed. So if we just jump here, you can see something interesting, and that is the symmetric algorithm cipher mode ECB, so electronic code book. And then you just initialize this, and here is Randall, so the basis for AES. So that piqued my interest, and this was the point that I just used as a starting point for my dynamic analysis. So now in this function ed, in this method here, we can also do a right click and say analyze, and then check out how this is used. So it's used by RF, and RF itself then uses ed, fv, method 0, and so on and so forth. So I eventually came here because this is the function that calls this ed and then additional functions, and I set my breakpoint right here. And this is where I began my dynamic analysis. So then I started debugging. I just hit start right here, and then I landed at this logging QA. If I step in here in this function, we can see that these other members are called, this AZ and this WS. And from here on out, I just kept stepping and wanted to get to the part that is interesting. Here is something that caught my eye when I stepped through this for the first time, and that is this flora here, which we will see again in a second. Now, if you continue stepping through here, you will at some point find yourself in a routine. It's this internal wait 1 that is invoked before by a sleep function. So I am going to go ahead and step through this so I can show you a little, I think, anti-analysis trick here. So if we go ahead and just keep stepping, you can see here that the malware waits for 31.5 seconds. And in this part right here, this is there to throw the analyst off, to make the analyst think that we're kind of like in some endless loop, or we stepped over something that may invoke a thread or something, so that we just step too far. While in reality, we are just sleeping for quite some time. So this is one trick to look out for. And here we are, again, if you recognize the name, in a function that is called flora, which we were able to read before. And this is actually where all the good stuff is. So right away, I'm going to set a couple of breakpoints here, and then we're going to walk through what all of these functions here do. Now, the first member here, it returns a bitmap, and this just uses this resource manager to get bitmap object. And next is this function here. So we're going to look at that. This is just going to return a list. It says year to array. So we have also this byte here. So a byte array is going to be returned from this. And then if we come up, you can see that some XOR operation is being done here. And this is going to be most likely just to deobfuscate whatever is input here. And in a last stage, this is also pretty cool. There's this gzip stream, and then there's this result which is returned. So I'm going to just set a breakpoint here because this seems to be where we want to go. And then also I am going to set a breakpoint at the returns of each of these functions, just to be safe. And I don't think there's anything else here at the moment that's of interest. So I'm just going to go continue here, and then just go through this one by one. Again, continue. And here you can see that there is a byte array. Still nothing that seems to be an executable here. Now let's go one step further. Now here is the interesting part, because after this is executed, we should probably have in this array something that we can use. Here is the result. So right away we can just look at this and look at that. Here's the M, here's the Z. And I think this is going to be the first stage. So I'm going to right click on this. I'm just going to say stay save here and throw it into my Snakekeylogger folder. And I'm just going to call this stage 1 bin. And throw this into the NSPY. Now before we continue, I'm going to take this stage 1 bin and throw it into detected easy just to see what we're dealing with. So here's .NET version 2 this time, and the entropy still says okay. The entropy appears pretty high, so I guess there's something more in there. Let's throw it in here real quick. Just have a look. Okay, this is a pretty weird string. Let's make this full screen again, and there you have it. There's again all of these Unicodes here. So this is something we don't want, and that is why I'm going to use de4 again, and just to clean this up and see if we can deobfuscate it. Let's run de4 on the stage 1 bin and see what happens. So I'm just gonna execute this here, and there was something detected, confuser X, so it's cleaned and all obfuscated symbols have been renamed. That's pretty nice. So go to this directory again, and you have the stage 1 cleaned, and I am going to throw this in here again, and then we can continue. And as you can see, if I click on this now, all of these weird symbols are gone, and we are again we have a method here now that is called sMethod0, and it's just easier to read. So let's continue stepping through this. First of all, there doesn't seem to be that much in here. We have some classes here. We have some forms. Just a lot of methods, as you can see here, which were named for us. And in the resources section, actually, there are, again, resources with weird names. This is about 42 kilobytes here. And this here is also quite large. So these are, I guess, again, the interesting parts here in the resource section. When I did my original analysis of this, I just went ahead and said, okay, let's just stop this debugging for now. Come down here, say start, and then I said, okay, break at the entry point. And when you then run this, you just get to this this main function. And here I just went ahead and stepped through this again, just to see what is going on here and getting a better picture of what the important parts are. Let's continue stepping here. So I am just gonna jump over this one, come in here. I think that I maybe wanna go ahead and step into this one, just to see a little bit what's going on here. So we have this mutex, okay, with the string 9. The string is here. So this might be something to ensure that the malware is not running twice. At least that is from where I know that mutexes are maybe used in the malware. Here is a sleep again, maybe again to throw the analyst off. So I just stepped over this here, and if we continue down here, this is maybe something interesting, as this just retrieves a folder path. So let's go in here, look at the string. So it's user app data roaming. I am just gonna open this up real quick, and then we will have a look. Just go view and hidden items here. So it was user here, app data roaming. Okay, and here we can see that there is this application here with the string. This is pretty interesting because, again, Hewlett-Packard turns up here. So also this pharmacy management system. So I think this is just going to be the malware. Before we had our first stage, we can even check this. So I'm just going to copy this out here into the folder that I made. And you can see the size is the same as the cleaned version of Snakekeylogger here. So we could calculate the hash and check if they're indeed the same, but for now I just want to continue here. So if this file doesn't exist, okay, something is going to be written. Let's step in here, see what's going on. Okay. Just gonna step over this, come down here, and this here is the last call that is invoked. Call inside of that again. Okay, so we have this switch here. This is 3, so we're gonna come down here. If I step over this, and then just jump in here. Okay. Step in again. And here, this is going to be invoked. Here is byte 1. This is a byte array again. And if we display the contents, you can see here that again there is this MZ. So this is probably going to be another PE executable. I'm just gonna save this here, and I'm gonna call this byte1.bin, and then we'll have a little bit of a closer look at this one. So if we're lucky, this could already be the last stage. So let's throw that in here. We have indeed an executable. Here are some private implementation details. This doesn't look good. So I guess this is probably going to be obfuscated again. Let's just go ahead and throw this into detect DZ. Here we have Goliath, obfuscar, okay. So this does indeed look obfuscated again. So I'm gonna use d4 dot again. And this time we're gonna use it on this byte 1 and just see what happens. So it detected this Babel and Goliath, and now it has renamed the symbols again. So here we have byte 1 cleaned. Let's just take this, throw it in here. Just minimize this. Open it up again. And oh, look at that. It's a little greeting for the analyst, I think. So that's not very nice. Also, this down here, these people that programmed this, I don't think they're very nice people when I read something like this. Okay, so let's see what we can find here. So we have here this COVID-19. We have something called Chrome Killer. That's interesting. Move file, multi-uploader, PW uploader, screenshot sender. Interesting. Okay. So this looks like we actually hit the payload here. Let's see if we can find maybe more interesting stuff. So this is also something, get foreground window. This get keyboard state, maybe hook key down, hook key up. This looks like typical keylogging functions. There's also something here called keyboard sender. Of course, with these method names that were just added by the deobfuscator, I would have to look into this in more detail just to check out what methods these are, what they do exactly. Here is a keylogger, so let's have a look into this. Identify key. So here are the F keys, delete and back. We have a couple of things here. This Avast antivirus, I guess. FileZilla. We have here Foxmail. There's Chrome, Chromium, all of these browser names. So this would probably be the part that tries to steal credentials from the browser, I'd suspect, with all of these names being in here. Now, this is also interesting, get Outlook passwords. Definitely gonna have a look into this. Here at some more interesting stuff we have here. Firefox, IceCat, Pale Moon, Sea Monkey, Thunderbird, Waterfox. So it seems like everything that's kind of Firefox based. Okay, this is also something, get clipboard data. This will also be interesting, yeah. So here I am on Malpedia, and I have the 404 keylogger page here. And one alias for this 404 keylogger is the Snakekeylogger. So this is the tag that the sample had that I got. And as you can see here, it says the info stealer can steal victim's sensitive information, log keyboard strokes, take screenshots, and extract information from the system clipboard. Further, it says it is notable for its relatively unusual methods of data exfiltration, including via email, FTP, SMTP, pastebin, or the messaging app Telegram. So if you want to check out these links here, just look for the 404 keylogger on Malpedia. I already looked at them, read up on some of the stuff, but now I want to show you something else, and that is the entropy of this, what I suspect is the payload. Now I already loaded this into Detected Easy, and you can see here that nothing here seems to be packed. All of the sections have a relatively normal entropy, I would say. Nothing that suggests there is anything or any large parts are encrypted or obfuscated here. So when I extracted this byte 1, which was a PE executable that I just showed you, where I think that this is the actual payload part of the malware, after we went through the stages that were just there to obfuscate this payload, we enter a method just named sMethod7 here. And there is always the question, we do, of course, have this this executable now, but it has to be executed somehow. So here, first of all, there is this create process with string 9. And this string 9 is actually the path here. And then this reg svcs.exe. If we come further down here, there is some more or less interesting stuff, because you have here this read process memory, then NT-unmapped view of section, then this virtual alloc x, this write process memory, again write process memory, and this just seems like there is some process injection happening here, because these functions seem to indicate that. So I think this is actually how the decrypted and deobfuscated payload here in byte 1 is going to be launched. If you want to know more about these process injection techniques, there is a video, a very good video by Malware Analysis for Hedgehogs. He also has a flowchart of all of these on his Twitter. He has it pinned, I think. You can take a look at that. It's a really nice chart that shows you different process injection techniques and which Windows functions that they actually use. So for this video, I think this looks pretty good here. I think this is actually the payload. This is actually where we wanted to get to. So I'm gonna end the video here. Keep exploring a little bit, see a little bit more about what's going on here, what this malware can do. And with that being said, if you came this far, thank you very much for watching. It has been quite interesting as a .NET noob to noob my way to this payload. So I wish you well, and I hope I will see you back in my next video.